In this video of data structures in Kotlin, we're going to look at queue. So, what is a queue? A queue is a linear data structure that follows the first in and first out principle. The first element added is the first one removed. So if you're in a queue and if you were the first one there, you'll be served first. And if you join the queue late, well then you will be served late. Like in a Domino's, you're given a token number, and if you're the last one there, you'll be the last one to be served. And there are two ends in a queue, a front and a rear. So the front is where the elements are removed. We call this operation dequeue. And the rear is where the elements are added. We call this operation enqueue. So, like in this grocery store, the elements are added to the rear, and the elements are removed from the front. Like this woman over here is the first element, so she'll check out first. The person at the end will be the last one to go out of the store. So the operations are add element to the rear and remove element from the front. We also have two other operations, which are peek and search. So peek is just, it's going to peek the first element in the queue and removes the element from the front. Implementation. So there are three implementations for a queue: array-based queue, linked list queue, and circular queue. In this video we're going to look at linked list queue because it's easier to implement and easier to understand too. And it's also dynamic sized because you can add as many nodes as you like, and it's flexible. Unlike array-based queue, it has no size limit. You don't have to define the size beforehand, and that's good. And there's circular queue, where the front and the rear are connected to each other, so it forms a circle. And it has a more complicated logic, but we can understand it later in some other video, and we're going to keep this simple for now. Okay? Next up, we have applications of queue. Well, music and video playlists. Media players use a queue to manage the next track. It ensures when one song finishes, the next one is ready to buffer and play immediately. Like in Spotify, you have queues, but those queues are a bit more modified and advanced too. They're like priority queues because you can slide up a song that you want to play first and swipe down to give a lower priority to a song that you don't like, and that's your Spotify queue. What about priority queues? Well, priority queues are also used in libraries like Glide or Picasso, which use queues to prioritize images currently visible on the screen. If you scroll past an image quickly, its load request is moved to the back of the queue or cancelled. And there are many more other applications of the queue. Well, what about the time complexity? Well, enqueue is O1, and dequeue is also O1, peek O1, but search is ON. So search takes linear time complexity because you have to visit every node to match which one of these is the node that you desire to search, to find. Okay, so in the worst case, you must traverse the entire list to find a specific value. Otherwise, your element could be at the second or third place. That'd be an easier case. Okay, the end. And but not the video. It's just the end of slides. So let's go and implement it now.